back to the concepts again, but I will give you something more concrete to do fairly quickly. Relationships are connections between tables on carefully designed matching columns. As this example shows, the orders placed by our sporting goods customers are connected or related to customers through a common customer ID column right here and here. Looking at the snapshot of parts of customer and order tables, you can clearly see that customer with ID of 3 has 3 orders placed on 3 different dates. This arrow should be pointing down to this number 3, and presumably for different products, although we cannot tell that by looking at the graphic. So the arrows connecting the tables on this and the previous slide visually represent the relationships, technically called joins, between different tables in the sporting goods database. Here we picked up the first of the 3 orders by customer ID number 3. You can see the connection between the customer and order tables, just like on the previous slide, showing that the order with ID of 12 was placed by a customer with ID of 3 and taken by an employee with ID of 71 on December 15th of 25. The next arrow connects the order with order detail table, where ID of 12 shows up twice because the customer ordered 2 different products in that order. The product IDs are 109 and 110, and the associated quantities are 1 each, and the 2 arrows connecting those with the products table show that the customer ordered 1 basketball and 1 basketball hoop and board. It's important to slowly go through this entire example, since the just described dynamic between tables using these joins is at the heart of the relational data model. It is RDM integrity rules that ensure that data and relationships are valid, consistent, and reliable. Entity or table integrity makes sure that no 2 rows in a single table are the same. Otherwise, we could have multiple rows representing a single instance of our sporting goods customers, with all the inconsistencies and problems that would entail. A referential or relationship integrity assures us that the values in the common fields of 2 related tables match one another. In particular, for our sporting goods example, each value of customer ID column in order table must match a single value of customer ID in the customer table. Next, we describe the concept of database keys, which then allows us to guarantee both entity and the referential integrity of the database. For the majority of our tables, a candidate key is a single column in the table with unique values, by definition, for each row of the table. Customer ID in customer table is one such candidate key. Customer ID in the order table, however, is clearly not a potential candidate key, since a single customer can place multiple orders over time and therefore have the same customer ID appear in multiple rows of the order table. Order ID in the order table, on the other hand, is a candidate key for the same reasons customer ID is one for the customer table. Although less frequent, the so-called associative tables, to be defined more precisely later, such as order details showed on this slide, have a combination of 2 columns, order ID and product ID, as a compound candidate key. Since one order can contain multiple products and a single product can be found in multiple orders, neither order ID nor product ID alone meet the uniqueness criteria of a candidate key. Combine the 2, however, and you have a unique order-product combination and therefore a legitimate candidate key. Null values, representing the absence of an actual value in a table, are tricky to work with and are best avoided if possible. They do have their legitimate place in certain tables, however, such as the product table of our sporting goods example, and will be discussed more shortly. Arguably the most important key in each database table is a especially or specifically designated candidate key that cannot and does not contain any null values. This key is called a primary key. A primary key, such as customer ID in the customer table of our sporting goods example, is typically auto-generated and thus always guaranteed, 1, to uniquely represent each customer, and B, to always exist, i.e. to never become null, and as such enforces our entity integrity rule. Is such an ID always the only choice for a primary key? There are other possible candidate keys, either single column ones such as customer phone number, or a combination of columns such as street address and zip code. Although we will discuss this more at a later date, you probably immediately suspect that something is just not right with these candidate keys to be chosen as primary keys. What if the phone number changes? That is obviously a problem. Same with an address that also has locational purpose that might have nothing to do with customers ordering sporting good products. Now it's time to get back to hands-on work with SQL. Because your customer table does not have any data at this point, it's easier to delete it and then recreate it by designating customer ID as its primary key. You can see that the table is blank when you switch back to Toad and right click on the customer table and go to see view details and then click on the data tab. Sometimes you need to make sure to refresh the view to make sure that there is really nothing there. But we haven't done anything to enter any data, so clearly it must be blank. Okay, so we're going to close this view and we're going to now open a second script in the 02 Relate DM folder, lecture subfolder of our class folder, that's going to have a single line of code after the comment which says drop table customer. Okay, needless to say, drop table command is pretty dangerous because you might lose a lot of data without warning. Okay, this is typically why only database developers and administrators have the necessary admin privilege to run create and drop table commands. Okay, because we are sure everything is fine, we're going to run the script which is going to drop our customer table. You will notice that right here. If you have an error, you're going to have to deal with it, but hopefully you don't. Then we're going to close the drop customer table script, and we're going to instead continue by opening the third SQL script called mysql 2_create_cust_tbl_pk right here. Okay, and it will look very similar to the one we've entered to our first create customer table script, except that at the bottom we're going to add the primary key constraint using the bottom part of the current slide and the red line at the very bottom, and that one says constraint bk customer, which is the name of the constraint with capital P, K, and C, but it could be really anything you want. The type of the constraint is primary key, and in the parentheses you designate customer ID as that primary key. Okay, notice that we made the editing of the script directly in the MySQL server editor instead of going first to the notepad. Generally, we use Notepad++, but sometimes for quick changes, we'll just do it directly here in Toad. When you save the change, the file will change. If you open it next time with Notepad++, you will see this added constraint at the bottom. Okay, once you save the changes, use the execute button to execute the script, and if nothing goes wrong, you'll get the customer table back again with all the same fields that you had before, with this one additional thing, which is the little yellow key right next to the customer ID designated as a primary key. You can also right click to view details, and under the columns tab you will see the little primary key designation for customer ID. Okay, we're going to close these windows and leave the Toad running, minimize it, and then we'll switch to the ACCDB2 supporting database, and we'll right click to on the customer table, open it in design view, and with the first field, customer ID, selected, we'll click on under Table Tools Design tab on the primary key, which will be the equivalent of adding that PK customer constraint from the SQL script we just finished. Then I'm going to save the changes in the design. You'll notice the little yellow primary key designation, and we'll close the design of the customer table and minimize access. And at this point is a good place to stop.